Okay, so mean value theorem. So in the last section, okay, so we were doing find the max or min values, right? Okay, what were the values that they were looking for? When they were, say, find the max value, you listed what? The y value. Okay, it's a height. Okay, so the mean value theorem, we're going to find an average. Okay, you understand the word mean, right? Okay, so it's an average height between some given interval. Okay, so average height of some given interval. That's all we're looking for today. Okay, so I'm going to scroll down and just give you the mean value theorem.
Must be continuous.
Yes. Okay, so the mean value theorem, there's two stipulations that must be true in order for you to use this. Okay, make sure you write this down. Okay, number one, the function must be continuous between your interval that is given.
Should be showing what you wrote.
Write what makes sense to your brain.
So
So
the same thing, basically.
I would probably write what I wrote, I guess. It's up to you. Okay, so mean value theorem. Two things must be true in order for you to use the mean value theorem. Number one, the function must be continuous. And number two, it must be differentiable. Okay, meaning, differentiable, that is a word. Okay, so meaning that you can't have an undefined derivative. Okay, so in that last problem, that one we did on the warm-up, we had a critical number that made the denominator 0 of the derivative. Okay, if that case happens within your interval, then you cannot use the mean value theorem.
So it's like easier help with
Kinda, yeah. You just have to check for that because there's scenarios where you might have like the sharp term within your interval, and if you have a sharp term, you just can't analyze the mean of your y values. Okay, so all that is happening is we're going to take the f of b minus the f of a over b minus a, and hopefully that looks familiar to you. What is that? It's the same as slope. Remember slope, y2 minus y1 over x2 minus x1. Remember that? That's slope. Okay, we learned that as average rate of change. Okay, so I abbreviated average rate of change as AROC. AROC. Okay, and all we're going to do is say that the average rate of change is going to be equal to the instantaneous rate of change. Okay, so your instantaneous rate of change is simply your first derivative. We can find the instantaneous slope at any given spot by finding the first derivative. Okay, so this is your big idea right here. We're taking the average rate of change and setting it equal to your instantaneous rate of change. Okay, are we ready for an example?
Yeah, sure.
Am I good to move? All right. All right, so my first example, I think I have it down here a ways. There it is. Oh, I have it done already. Oh, I see. I'm on the wrong. Hold on. All right, so I'm just going to pull out an example here. There we go. Okay, so here's our first function. We're just going to find the mean value of the function between 0 and 1. Okay, so the first thing that you need to do is you need to say, first, is this function continuous between the values of 0 and 1? Okay, so is there anything that would make this function undefined between 0 and 1? Okay, so the only way you would have an undefined value is if you had an x in the denominator, or potentially a square root involved where it was not existent. Okay, so this is a parabola. A parabola is continuous. What's that? If the denominator is undefined. Okay, so this is continuous. So the first thing that I'm going to do is find my average rate of change. Okay, so how do I find my average rate of change? Okay, good. Okay, so I'm going to take my 1, see the 1 over there from my interval, and I'm going to plug it into the function. Can you do this mentally? You might want to write this down. Why? Because it's not that hard. 1. Why am I plugging 1 in? Oh, because I'm doing the average rate of change. So average rate of change is like y2 minus y1 over x2 minus x1. Yeah. Okay, so this is my like y2 scenario, right? So 1 plus 2 is 3. 3 minus 1 is 2. Okay, so that would be my 2. We can find our y1. So if I plug, if I plug 0 in, we get -1. Okay, so we basically have 2 minus -1, so we can call that +1, over 1 minus 0. So would anyone else agree that that makes 3? Okay, so now the second part of this is I'm going to find my instantaneous rate of change. So my instantaneous rate of change, how do we find that? Derive, it's just the first derivative. So what is the derivative of my y function? 2x plus 2. So now, the next thing that I want to do before I decide that I'm going to use my mean value theorem is there any place that makes my derivative undefined? So for the blue function, is there any value that I cannot plug into the x value? That I can't, like that would make the denominator 0. No. There's no denominator, so there's no restriction. So this function is differentiable on all values. So I can take my average rate of change and set it equal to my instantaneous rate of change. Okay, so if I solve that, what would I get? Good. Okay, so you get a value of 1/2. Okay, now before I decide that this is in fact my solution, I have to go back and make sure that the value that I just got is within the interval. Okay, so is 1/2 within the interval? Yes. Okay, so they like to use C for your average value, so I'm going to use C and call my C 1/2.
Can't you just find the mean of the interval without using this?
No, you gotta do this crap.
Because if like in between 0 and 1 then always be in between.
It's not always going to be halfway, not always, because it depends on the function. Like, this one grows fairly, what's the word? Gradually, but it's possible for a function to do a whole bunch of stuff in between your interval. So you can't just assume that and use algebra. You have to do more than that and use calculus. C is just your average value, or your mean value, excuse me. Okay, should we try one more? Let's do one more and make sure that was a little harder.
Yeah.
Let's do a little harder. Okay. I'll try a little harder. We'll try number 2. Okay. All right, so what is my first step here if I'm going to find the mean value? Okay, now before I start it, I want to make sure, is this function continuous? Is there any value that makes this function undefined between our interval of 0 and 1? Is there an x in the denominator? We're okay. So this function is continuous, so let's go ahead and find the, let's do average rate of change first. Dividing by 0. So there's no value that would make this undefined. No. So like, well, you have to see if dividing by 0 makes it undefined. She said, when is it undefined? And I said, when you divide by 0. Oh, okay, so like for example, let's say you have something like x plus 1, like that. Okay, that would be a scenario where -1 would make the function not continuous, right? Because 0 makes that denominator undefined.
So this one doesn't have it.
Correct. This one is continuous. So far, so good. Yes. Well, you just can't do it. That's just it. You just say can't do it. Done. Yeah.
So you get to the end of instantaneous.
Okay, so how do I find my average rate of change? Okay, so can we do this mentally? You guys with me? If I take 1 and plug it in, what's 1 to the 2/3 power? 1 to the 2/3 power. 1. 1. Now if I plug 0 in, what's 0 to the 2/3 power? 0. Okay, on the bottom I have, I plugged in 1 minus 0, so our average rate of change is 1. Okay, now the next thing I have to do is find my instantaneous rate of change. How do I find my instantaneous rate of change? What? Can you wait 5 minutes? Then hustle. What's my instantaneous rate of change? How do I do that?
2/3 x.
Good, I derive it. 2/3 x to the -1/3. Now, if I rewrite this, I have 2 over 3x to the 1/3. Okay? Is this function differentiable between my values of 0 and 1? What is the one value that we cannot have? 0. It is not differentiable at 0. So, we can't do it. Can't do. That's it.
That's the answer.
That's the answer. No, you just can't use it. There's not another way around it.
So we can
You either can do it or you can't do it.
I can't.
Okay, so you would have to say why, not at x equals 0. So just so you know, there's only 2 on your worksheet that you cannot do. 2.
So if you're right, can't do for all of them, so it's
Yeah, 2 out of
16.
16. Should we try one more? Make sure we've got this. Let's do a fraction one. Actually, let's go ahead and do one off of the worksheet. Let's do that. Okay, what do I do first for number 7 if I'm looking for the
Average rate of change.
Okay. So first of all, is this function continuous?
Yeah.
Yes, so we're good to go. Okay, so our average rate of change. Okay, if I plug in 3, so 3 times 3 is 9. 9 minus 9 is 0. 0 to the who cares power is 0. Okay, now if I plug -2 in. So -2 times 3 is -6. -6 minus 9 is Negative 15. Ew. To the 2/3, so negative 15. Ew, ew, ew. Okay, so we got
Ew.
I'm gonna say plus because we have minus and negative. What's 15 squared?
Like 195.
What?
It's 225.
It comes out to 15?
Yeah. Negative. No, this is going to be
2/3? So you do 2/3.
You're right.
So the cube root of. Give me what's 15 squared? Anyone? 15 squared. 15? 225. There we go. We're okay with that. Okay, and then we got 3 minus negative 2, so I'm going to call that 3 plus 2. So this one is the cube root of u over 5. All right, so now instantaneous rate of change. No, that's not the answer.
But for
the average rate of change. Okay, so how do I find instantaneous rate of change? It starts with a D, derive, there we go. Derive it. Oh, I didn't hear. So negative 2/3, 3x minus 9 to the negative 2/3 times the derivative of the inside. What's the derivative of 3x minus 9? 3. So if I simplify that, I have a 3 over a 3, so the 3's can cancel out. Yeah, I see I have a 3 in the back, so I have 3 times 2/3 basically. So the 3's cancel, so I have a negative 2, and then I'm going to throw that quantity into the bottom. To the 2/3. Oh, yeah, 1. Thank you. Good catch. That's weird that I. Okay, so the next thing I want to think about is there anything that makes this function not differentiable that's within our interval? So which value is going to cause a problem?
3.
3. Uh-oh.
Oh my god.
Can't do
3.
Uh-oh. So yeah, that's within our interval, so we cannot do this one. Why? Good question. Because this is not differentiable at x equals 3.
So whenever you're doing an equation like is a fraction, then that was like non-differentiable.
This is 1, 3 minus 0. Can't do.
Yeah, but you can still, like if our interval would have been from, let's just say, negative 3 to negative 2, we would have been fine. We could have done it.
So if the interval is like really large,
Can't do.
Yeah, but you can't do it unless it's a closed interval.
okay, so then what would you do if it was negative 2?
Negative. Then you would set your average rate of change equal to your instantaneous rate of change. So we take this and set it equal to that and solve. Yeah. Okay, let's try another one. Hopefully one of these are differentiable. Ooh, should we do I feel like number 10 is one we should look at.
Yeah.
It does look pretty nasty. Let's skip to 10. Okay, so first of all, is there any value that would make this function undefined?
No.
Yes.
1, 0.
0. Okay, right, good. So 0 is not within our interval, so we are okay. It is continuous between 1 and 3. So let's do our average rate of change. We're going to plug 3 in. So if I plug 3 in, my top is going to be 9 minus 9, which is 0. I like that number. And if I plug 1 in, that's going to be 1 minus 9, so that's what? Negative 8 over 2. Anybody else get negative 4? So 4 over 2. Anybody get an average rate of 2?
Yeah.
Okay. So next step, we're going to find our instantaneous rate of change. So instantaneous rate of change, what method are we going to use to derive this? HODI high. So our HO is 2x times the derivative of the high, 2x, minus the high times the derivative of the HO, all over the HO squared. Make sure you put that 2x in parentheses because we got to square the 2 and the x. So our top is going to be 4x squared minus 2x squared plus 18 over 4x squared, which can be simplified to 2x squared plus 18. You gotta distribute the negative. There's 2 negatives.
Yeah.
Negative, negative.
Oh, I missed this.
Yep. For 4x squared. Because you have to square the 2 and the x. You're squaring the whole bottom. Okay, so what? X squared minus 9. So I can go even one step further and divide that by 2, right?
Yep.
So that would just be x squared plus 9 over 2x squared. Okay, so that's as far as I can go simplification-wise. So next step, is this differentiable between our interval? What's the one value that makes this function undefined or not differentiable? 0. That's not within our interval, so we are okay.
Nice.
So here we go. We're going to set our average rate of change equal to our instantaneous rate of change and solve. Okay, so what's my first step here? Multiply the 2x squared, so that would make 4x squared equal to x squared plus 9. Okay, and then what would you do? Subtract your x squared. So we have 3x squared equals 9. Then what? Divide by 3, so we get x squared equals 3. And last step, square root that. So we would get x being the square root of 3, and technically plus or minus. So which one of those fits within our interval? The positive value. So our c value is the square root of 3. Good there? Okay, so we have a guest speaker. I didn't tell him you were coming, so that was shocking information. So this is Dylan Livingston. He is a Belgrade alum and current tech student over in Butte. And so he's here to tell us about his experience, answer questions that you might have about college.
What's that?
Is it worth
If you go
it?
to Butte, I'll tell you all about
Ooh,
it.
he's got some good info for you guys.
I'm not yanking your chain. I just paid tuition last night. It's nice to.
You should tell him how much you paid.
I paid $3,800 last night for a semester.
Right?
Looks like I'm staying.
Yeah. And then living expenses, I expect to I'll live off probably about $1,200 for the semester. So About $5,000.
$1,200.
My rent's like $200 a month.
Good Lord. That's like a month for me.
Yeah.
Jeez.
So, all right. So like she said, my name is Dylan Livingston. I graduated from Belgrade High in 2013, and then since then, I've been in Butte for 4.5 years. I'll graduate this May. Got one more semester left with a bachelor's in environmental engineering. So our department head wanted us to come into our former high schools and talk to students. I think I've seen some of your guys' faces this week. I've been around. So I'm sorry if you have to hear it again, but maybe you'll hear something new. I've kind of gotten better as I go along, so that's always a plus. He wanted us to come talk to students. I'm not going to throw a bunch of numbers at you and try to recruit and do all that stuff. Mainly it's just talk to you guys about Montana Tech, what it has to offer, some experiences I had, and then I might show you a little bit of some math that I used in my degree. And so, who all in here is a senior? There's 2. Okay, the rest of you guys juniors? No sophomores, right? Because this is what class?
Calculus.
Calculus.
Mm-hmm.
Is there Calc 1, Calc 2, or is it just Calculus?
Just calculus.
Okay.
Mm-hmm.
So I took this class my senior year, I think. So I had Mrs. Nolte for advanced algebra and trig as a junior. Do you still teach that? Or is that
I do.
It is.
Yeah.
Mostly seniors, or are there some juniors in
Mostly seniors. Yeah.
there? Okay. So first off, about me and math, I didn't really like math in high school. I wasn't the best at it, and I never really thought I would use math. But I took the ACT, and my 2 best scores were reading and writing, and I'm an engineer, so that doesn't always tell you everything about what you're going to do, because anyone can do anything they put their mind to. That's really what it came down to. So in college, first off, for engineering, if you guys are interested, I took 6 semesters of math and 3 semesters of calc-based physics. So we use calculus quite a bit, and you're exposed to a lot of calculus. And I don't know if it's you and another gal who's here on Wednesday asked me why we have to learn everything if we don't use it all. That's a good point, and that's something I ask my teachers every semester. But it actually keeps building on itself, and the more things you're exposed to, the more things you're able to use later. It kind of gets put in your toolbox, if you will, as a professional. So don't give up on calculus if you're like me and wasn't quite sold on it. You will use it, and it does get very, very interesting how you do apply it later. And everything builds on each other. And then lastly with that, your algebra skills become super, super refined. Because like probably this problem from here on is algebra. So there's not even much calculus in there.
Hardly any, yeah.
So your algebra skills will get much, much better the more you're in school. So first off, Montana Tech, the one thing I like to tell kids is 2 things. The return on investment is very, very good. In fact, it's best in the state statistically. What that means is the money you put in for tuition and your fees throughout the course of your education versus the money that kids averagely make when they leave is the best. They have the best return on what they put in. Secondly, job placement is a huge, huge part of Montana Tech and success because they like to produce engineers and other degrees. I'm kind of a plug for the engineering side of things right now, but there are other jobs available at Tech that aren't engineering, but for the most part, I know about engineering, so I'm going to stick to that. My department in particular, environmental, has a 98% job placement rate. It means if you graduate, you have a job waiting for you, unless you're
You should say that one more time, because that was huge. Did you guys hear that?
98%. I graduate in May and I already have a full-time job.
It's crazy.
So it's a very, very good thing. There's a lot of kids who will go to college in the next 5 to 15 years and they'll spend a bunch of money and they don't know what they're doing and they'll continue to spend money and they'll set themselves up into a hole. It's not to scare you guys, but that's real life, and it's time for you guys to start thinking about that. You just got to be smart and use your resources. And that's why I like Montana Tech, because they've got the resources and the professionals to help you guys think through these situations give you guys the tools to be successful, not only at just tech, but they'll be there to help you. They'll answer your questions about anything, which is really nice. The other thing is we've got a lot of good funding coming into the university. Luckily, Montana Tech has produced some very, very high quality engineers in the past. They have that reputation, and they have some engineers that work in some big time jobs across the nation and the world. The CEO of ConocoPhillips is a Montana Tech grad. There's Montana Tech grads everywhere. I know at one point, I didn't share this yesterday, but I remembered it last night. I was talking to a guy. He came into one of our, I think it was soil and subsurface remediation or something like that. He came in and was talking about his time spent on an offshore oil well, offshore oil rig. There was 18 guys on deck, 12 of them were Montana Tech grads. It's a pretty good reputation. We are ABET accredited, which means that's a national and I think now international curriculum basis. So they meet every year to make sure that we are doing the best we are taking the best engineering curriculum we can out of any place else in the world. And if we're not better, we're at least the same as everybody else in the world. So we are still leading the pack in that aspect. So is it worth it? I don't know which one of you gals asked that. If you play your cards right, college is worth it everywhere. If you play them right at Tech, it's absolutely worth it. And so other than that, a couple things about Butte. I know I wasn't sold on Butte when I was in high school in Belgrade, but it's not a bad place. If you guys like small towns, Butte's a great small town. They welcome you in with open arms. You get to know a lot of people. It's a pretty close-knit community. And Montana Tech also is a close-knit community. There's about 3,200 kids with graduate students. I go to class, especially now as a senior, with 8, 9, 10 of the same kids every single day. So it's even smaller than this classroom. I think the biggest class I ever took at Tech was about probably 100 kids. But if you go to freshman chemistry and MSU, you'll be in a room with about 300 others. So if you like that personalized small town type feel, Montana Tech is a great fit. It was for me. I got a chance to meet a lot of people. I got a chance to branch out. I know kids from all over the state. In fact, if my mom didn't hate me for it, I'd probably go spend Thanksgiving with some of my buddies who live across the state. Just you make really good friendships and they become family. So that's a really cool aspect of Montana Tech. I think that's about it as far as tech goes. The engineering degrees offered, obviously I'm going to tell you to go to environmental because that's where I was and I really like it. And I'll tell you why after this one. There's civil, petroleum, mechanical, metallurgical, I keep missing one, mining. There might be one more, but those are the 5 that come off the top of my head. So the 2 I'd recommend right now, just based on where we're at as a nation and as a state in Montana, would be environmental for 1 and civil for 2. So the 2 things that probably aren't going to go away fast is our need to address some environmental issues, especially in the state of Montana. My job that I'm about to accept, I'll be working on a Superfund site west of Butte and Anaconda, and I could probably work there till I die and it will not be done. They could probably be working on the Berkeley pit until most of us in this room will leave the earth, and it will not be done working on it. So that just kind of gives you an idea of how much work there still is to be done in both the environmental field and some other engineering fields. Then also, I don't know if you guys pay attention, the big focus of our nation as a whole is infrastructure right now. There is a huge push to revamp a lot of our design in the country. I think Bozeman has a D- for infrastructure. So that's just an example right there. I was driving through Bozeman yesterday at 2 o'clock in the afternoon. I was backed up from Main Street all the way back through the light past Town and Country. And I was just like, this is ridiculous. 2 o'clock on a Thursday. And the roads can't get bigger in Bozeman. That's what baffles me. I don't know what they're going to do. But one of you guys can solve that problem one day. So other than that, that's about it for Montana Tech. Talk a little bit about the career fair. There are companies that come, about 150 or so companies are on Tech's campus twice a year to recruit Montana Tech grads. That's how much they want us, which is a good feeling to have when you're going to school. Our big thing is we are in demand, and we definitely are. to produce high quality engineers. Pretty good investment, and you set yourself up to be a very good professional, whatever you want to be. You can have an engineering degree and never use it, but it is a ticket to something else. So think about that. And then you want me to show them some calculus that I use?
Do you guys want to see any calculus?
It's not like great examples, and I'll be completely honest, half of it I don't remember how to do because I don't use it anymore. But I'll show you some of the stuff I use.
Here, I'll let you sit.
So you'll reach this point in your education where you find out that a lot of the stuff you'll be learning by hand you can do with a computer. But that's not to discourage you. That really ticked me off when I was in your guys' shoes. And it really ticked me off when I was taking a class where the first half we did it by hand and the second half we did it on a computer. But I tell you what, if you run into an issue on that computer program, you don't know how to do the calculus, you're dead in the water. Your boss has knocked on your door at 4 o'clock and you don't know what you're going to do. So think about that. And so I can show you, so like I said, I took 6 semesters of math at Montana Tech. You start off, I believe, after thinking about it last night, I think pre-calc is part of our curriculum. You can obviously come in above pre-calc or below, depending on your ACT score. I came in below, so I took college algebra. And then pre-calc, and you got calc 1, 2, 3, and then calc 4 we call DiffEq, so that's intro to differential equations. Which really aren't that bad compared to, yeah, so, what's that?
They're more complicated. Because we're like about not the same.
Yeah, so, especially, so calc 2, I'll tell everyone, is like the worst. So calc 2 by far, at least, I can't speak other universities, Montana Tech, calc 2 is the worst. Pretty much, if I could take like 3 words and describe it, it has to be more than 3, but you integrate everything possible ever. That's the class. They teach you how to integrate using every integration tool ever made up by man. I was talking to her, like, use subs with trig functions I've never even seen before, had to manipulate them and using use subs and stuff like that. And then you get into some series and some stuff like that, which is pretty much like a fancy word for like summation. It's like a visual plot of summations and stuff. They're really weird. I've actually blocked them from my memory. But see, I can be just honest with you guys. Like, you know, you're gonna learn a lot of stuff, and a lot of stuff you'll use, and there's stuff you won't. But you never know what you don't know, and you never know what you will use. So you learn it all, and that's fine. And so getting to this, calc 2 is hard. Calc 3, you kind of take like a weird jump. I know I showed the test yesterday, and like this first test, there was hardly any calculus on it. So like that one, you're just pretty much isolating and setting those two equal to each other. You're eliminating the parameter. Pretty much means get rid of the natural logs. So there's not like, I mean, this one, you guys will have some exposure to Cartesian and polar coordinates in high school. In fact, you may have already seen stuff like this.
The next one, show them the next one. Now, this class has had more trig than the last class. So like this, I guess we do this question. This is completely straight trig.
Yeah. Don't get like.
Oh, yeah. Argument. Yeah.
Yeah, so they don't yeah, you guys can do that one.
Oh, yeah. I'm not good lost.
And then this is just like dot product stuff, vectors.
Yeah, you guys have word vectors new. It's
Really very easy. Like if you guys just look at the math, like it's not hard math.
Yeah, it's like so it's like you got your U vector, which is made up of those three pieces, the I, the J, and the K, and then you got your B. All you do is you just add your like terms. Oh yeah, which is the same idea. We don't use that.
Like
So it's not that we didn't know that.
We're giving copies.
like dot product super simple.
Yeah.
You just times the i's, times the j's, times the k's. I mean, you're pretty much
So like I know. So it's the idea of vectors. So it's
What's up, Jane?
Physics. So vectors.
Yeah, with psychology, yeah.
Is that
What was your question?
vectors?
Yeah.
Yeah, you're pretty interested. That looks. Does that look familiar at all to you? That notation at all?
Yeah, I do that whole Don't take it.
Physics is awesome.
I enjoy physics.
I'm not saying in class.
So I can show you what time are they done?
10, yeah.
First off, before I get crazy into like showing you guys some stuff, anyone have any questions for me? I don't care what they are. I'm not on contract here. I can say whatever I want. Just kidding. If you guys get to school and you use this physics book, email me. I'll save you like $400.
Hey, that's great answer.
So this textbook is
That's a fat textbook. It's 1,600 pages.
Yo, that's some
This
dope.
one.
Read all that one,
From
right?
like
That's some
736
knowledge.
1,600.
But they're generally
Oh yeah, I was getting
So here's some integration you use. So this is physics. This is physics 3. So this is electricity and magnetism. You use integration a lot for electricity and magnetism. You're talking about fluxes of electricity. So it's like an area moving across like a distance. So it's kind of like a volume, but it's fluxes. I wouldn't say it's always changing, but it's not always constant. And so like for this one, the example is you've got a spherical capacitor, radius A, surrounded by a concentric spherical shell of radius B, and the electric field between the spheres is directed radially outward when the inner sphere is positively charged. And so what you're doing is you're going to write an expression for the potential difference between the two conductors. And all you're doing is just setting up pretty much kind of it looks yucky because it's got all variables, but you're just pretty much going to integrate that and simplify it, and then substitute what you know from the previous example. And so, like I said, we don't use a lot of calculus, but the calculus we use, I mean, you have to be able to just integrate that. But that's the only calculus in the whole step. Everything else is substitution and algebra. And all we do time and time again is we manipulate and simplify. That's pretty much my job. And I find problems, I manipulate them, and I simplify them into the answers I want. And so I don't know what all I'm going to use when I have to solve a problem, but I have to have a pretty big toolbox to solve a lot of problems. So that's where learning everything comes into play. And I'm weirder because I'm environmental. I do a lot more chemistry. Don't do quite as much calculus. But I did use some calculus in a couple classes in the past, especially with air. Welcome back. When you're doing air stuff, you use a lot of calculus, and you have fancy programs that do a lot of calculus for you. But I can show you at least one example of some stuff I used this semester in calculus. It was like we looked at it yesterday, there's really like nothing to it. But so like a big part of like my learning is all about contaminant fate and transport. And this one might have been the one with a lot of the hydrogeology.
Who are the people that are interested in engineering?
Wait, can I see those hands again? For you that are going to school next year, do you know what you want to do? Yeah. I was a late applicant in Montana Tech, so if you don't know, it's not too late. That's my biggest thing. I wanted to find that sphere again that I had up yesterday. That thing was kind of cool.
Oh, the box.
Yeah. You should have memorized that page. Remember that one?
That's a lot of it. That looks like a step right.
No, it definitely looks
I know. Dude, you're gonna look like Gavin Louise, bro.
I think it's like just because I'm Oh no, not that. We're talking about that. Okay, because not that
Wait, what's his name? Dude, no way, Walt moving. Yeah, like you might leave too.
Yeah, I can find stuff in here all day. Kind of show you some examples. I think that's about it.
How did you?
Yeah, I agree with
So for this one, don't you just have this over?
Yeah.
Whoa!
Yo, is that a hypothetical cube?
Yeah, I mean it is. What's that?
We're talking about hypothetical shapes, so yeah, we got one worksheet that it was like.
So what if the answer's wrong? Then it's anything that you want.
Yeah.
That works. I can be pretty good at that.
The answer I want is the right answer.
Oh, yeah.
It is. But like, that's not a hard integral.
It's just so many variables. You know, if I did that problem, my answer would be 1.
So look at your answer.
No, it's 0.
You integrate E.
My answer would be 2. I was only 1 off.
Luke, did you?
Well, Michael, I can do it. Yeah. You just wait, bro. I'm getting
I can actually, Maybe once I got the
These ones so you have to use and then you can set the average exchange.
Oh, that's because I use liquid. And then I put like this.
Have you read it this in the bottom? It's not differential at 3, which is
I like that.
Zero.
my god! We're gonna just start lives, and we're just not
yeah, I went in there and I was like, hey, I'm really behind it. You didn't care.
Stephanie, you're well, right? Yeah.
They smell it.
Mine is not good because I don't Oh, I know that extra chest. Did you notice they put sounds like seriously? Yeah, I just don't care. It's fine. It's whatever. Well, I got mine's just not in there. That's cool. Oh, really? Stephanie, my style's down. Did you do your Oh, I'm sorry. There's yours. I'm gonna go double check and see. Did you do your princess? No. I think so. I didn't even see over it. I just wanted to get like this one's probably mine. We're gonna say that. The third yeah, they bring like powder. They taste really good. Like just crumble it in yogurt and eat it that way. Sometimes they don't have it's basically just crumble. I mean it as a crumble. No, that you know,
Yeah, you're trying to set it up.
What? I don't even know what you're the best. I'm just sitting here all day.
There you go. There's your warm up.
I have this water.
Yeah, I'm not sure. I thought at first you said how to spell it. I was like, it's right there.
That's like what my mom like. Sorry. Do like a bar, protein bar, thing. Oh my god. Look at this
Okay, you guys do that warm up. I'm gonna go get coffee.
My account's signed in. I didn't get you right now. Okay, just sign it again. What is this? Oh, I thought you said, oh.
What's your teacher? Never mind.
What is the final? Oh, I don't know. Oh my god.
Why? I'm kind of conflicted. Is this something?
It seems like Sharon had feelings. It's not. Is it the PSD 47? Yes. Okay, so it's government schools?
No, it's like so fun.
I was pretty sure that
Give us a talk. They're terrible.
why do you ask it? Okay. I'm so mad because I had all those answers right. Nor did she move the back. Yeah, I just got this.
Yeah,
somehow I the same amount of points off even with those answers.
I want to try.
It is better than nothing. It is better than nothing. I mean,
My mom has gap year course.
It might be.
Like where it's a library. I feel like I'm gonna make it big. The girls are at 6 and the boys are at 7.
What?
Oh my god, I went to the wrong one then, didn't I? Yeah. Are you going to wow. Yeah.
I'll just play the video or at least the shape. It's on YouTube. You can get it.
True. Kind of personal. Wow. You want to hear about this?
That's so nice.
It's only regarding
I've never won one. That's true.
I'm here.
Figure it out.
I have smooth. Yeah, like it is the. Yeah, you can pull it up for it.
Yes.
You know what? I feel like the visual demonstration she was a lady.
So since you collaborate, I like your hair. It's cute.
Alright, who's gonna do the warm up for us?
I can do it.
I'll do it.
Got lots of fun.
I don't quit on my fries.
So should I pick somebody randomly then?
No. If it's a prize involved.
Yeah. I got it. You guys are prize involved? Okay, I vote the prize is involved.
It's fine. You know what?
Lucky number 23. Is that new? I know what it is. Number 22. Is it?
I'm going to start.
There is something brutal on there.
Number 4, Basil.
Yeah, buddy.
Some kind of sugar.
Bring it to
I don't
you.
know what is on that thing.
You got it. You know what you're doing. You don't need me.
I don't know if it was good. I don't know. It tastes like
I'll be your support group.
yeah, seriously, like, don't
Oh my gosh, my hands are so sweaty. I'm so sweaty from strength. Okay. Now do the inverse, right? Yeah. So bad. X. Oh, I hate this. Do I need to write bigger? I'm gonna write bigger. You have good handwriting. Thanks. Okay, now we're pop points, right? Yeah. Gosh, I can't draw a point either, so it's fine. Oh, I heard fruit snacks. Can I like zoom in? Okay, good. I can zoom in.
I mean, like one before. Usually
That's so bad. Whatever. 1, 4. I'm gonna hurt this thing.
My software cleats still aren't here.
2, 7.
And I ordered them a long time ago. It's really bugging me.
3, 12. Should I write points?
Yeah, a couple. 2, 7, 3, 12.
I don't like eating usually when I have like odd days, I have actual lunch. But every day I work here, I eat food.
Soccer cleats. Ooh, I'm gonna track my soccer cleats.
Where'd you get them from?
Soccer.com.
Okay. That didn't go through a point. That's okay.
Customer
17.
I really need these socks.
12.
It's in Illinois. My socks are in Illinois. So I ordered cleats and then I ordered socks. And I really need my socks more than my cleats, honestly, because I have to have these socks. Because it's part of my uniform. This is not good.
Oh my gosh. Look what it just did.
Okay. Now I gotta try my socks.
It like connected.
So wait, did you write the domain?
Oh yeah. What's the domain?
So you list your domain of both the original and inverse, please.
Yeah, I know.
Oh my gosh, I cannot write. Soccer.com. I don't think it's that one. I think it's this customer
Just do what you just did.
I don't know. I'm probably wrong. I'm not gonna.
I don't really care.
I did it, Stephanie. Good for you.
Hey, my soccer cleats are out for delivery in Belgrade, Montana.
They're here.
Well, maybe they're in a vehicle.
Okay, Nathan's packet, he said it was in Belgrade, Montana for like 3 days in a row. It's not. It's not in Belgrade, Montana.
Cause okay, so that was 10 days. They better get here today. Cause if they don't get here today, then I doubt my soccer cleats, my soccer socks will get here in time. It's iffy. I'm really pushing my luck.
Well, yeah.
I think it is.
Oh yeah.
They're forcing us to think positive.
I like the graph, I like the right arm, I like the algebraic piece behind finding the inverse. I like the domain, I like the graph of the inverse. Looks perfect.
Oh, I was definitely like this.
Does anybody have any questions?
Okay.
Oh, yeah, shoot.
So you know how with the domains we did like so it's x is greater than equal to 3. I got that. Do you have to do it for the other one too? Like x is greater than equal to 3?
Oh, yeah, well, usually I do say that.
I always just put one domain because they're the same thing.
Not this
Like,
one.
well, what do you mean? Then what's the other one?
The domain of this one? The domain of this?
Well, that's 0.
0. This one.
Do you just need the one for the inverse though?
Depends on when I ask.
Okay.
I mean, on this one, it doesn't really say.
Write the rule for an inverse.
Depends on if I tell you.
So we did 3 in class.
Skittles, please.
Alright, who has a question on the assignment?
The composition.
Ooh, the composition. Yeah, okay, so I didn't go over the composition or how to do composition. So let me inform you how to do composition. Oh, no. Just watch. Just learn. If you didn't do your composition on this worksheet, I won't be upset with you because I didn't teach you how to do it. Okay, so let me just show you what this means, and then you'll know, I guess. Okay, so for question number 1, did you find the inverse? Did you find the inverse by doing this? Actually, I like this better, personally.
I'll put it in a fraction. Wait, can you put like decimal inside of the square root?
Technically, no.
Well,
Well, I mean, I guess you can, I guess. I probably wouldn't dock you. You're welcome. So anyway, you get a inverse of the square root of 5x. Did anybody else get that? Well, did you know that 0.2 is like the same as 1/5, and if you divide by 1/5, that's the same as multiplying by. There it is, 5. So composition. Does anybody know how to do composition? Has anybody heard that before? So composition is the idea of plugging a function into another function. So the notation for this would be f of -1 of x. So all that I would do is I would take my inverse function and plug it into the x of the original function. Okay, so if I plug that in, I would have 0.2 times the square root of 5x squared. Did you follow that? So I just plug that green into the x of the, I said that too many times, the x of the function. And now I would simplify it. So if I have a square root that's being squared, what happens? They do cancel. So now I just have 0.2 times 5x. Anybody know what 0.2 times 5 is? Which, by the way, is the same as, because I like fractions better. See why? 1/5 times 5 is 1. Yeah, so guess what this equals? X. Which, by the way, what was the whole point of all this stuff in the first place? We set the y equal to x.
So what was the?
So that is a proof. So the idea is, if you do a composition, if you plug the inverse into the original function and you get x, that is a proof that you will do in fact have the inverse. Super. What other questions do we have? Tegan.
Number 10.
Number 10. Oh, I was expecting a word problem. Okay.
We can do those too if you'd like.
Well, this depends on. Yeah, I thought the word problems weren't too bad. I wouldn't mind going over at least one of them. Okay, so where did you start on this? Did you graph it first? Did you find the inverse? Algebraically first. Let's start there. So we got x equals -12y cubed. What would you do first? Okay. So x over -12 equals y cubed, and then what? Cube root. So my inverse function is the cube root of x over -12, which I would allow you to leave for today. For today, because our focus is on finding inverses. Okay, so there we go. Now let's graph these suckers. What does x to the third look like? Whoa. X to the third, a cubic function. There it is, John Travolta. If I have a -12 in the front, what does that tell me? It is. He has a slope of 12, and also, what about that negative specifically? Flips upside down. Okay, so his left arm goes up, his right arm goes down. So his vertex is going to be, whoa. Where'd I go? There we go. Vertex is right at 0. And then the slope is going to be, if we go to the left, 1 and up 12. Notice this is going by 2, so be very careful here. This is almost, I mean, it almost sucks right into the y-axis there. So see if you can draw a good John Travolta there. Oh my gosh, that was so good. Okay, so now what I can do is just take my points and invert them. So what are the points that are going to exist on our inverse piece? So yeah, -1, 12, -1. Okay, hold on. I'll just write these points for you. So this one's -1, 12, and this one's 1, -12. So we could have 12, -1, obviously 0, 0,